Welcome to this video. I'm very excited to share to you the compilation of CWI practice question for Part A of the CWI exam. This compilation of 50 questions is a set of realistic Part A questions composed of welding processes and welding safety that will help you, yes, you, the exam taker, to be familiar of what questions that will be asked during the exam. Just like any other certification exam, practice is the key. I explained in this video the correct answers and the reason behind those correct answers. As well, of course, the wrong answers. Why? Not only it will reinforce your knowledge of the topics of the exam, but it will help you eliminate the wrong answers during the exam. Don't forget also the Udemy course as well in the video description. It's free, so grab it now. It will help you pass the CWI exam as well.
This is the solidified layer formed during stick welding and must be removed. Letter A, tungsten. Letter B, porosity. Letter C, slag. Letter D, arc stripe. So tungsten does not pertain to stick welding because the welding electrodes of stick welding does not contain tungsten. Letter B, porosity, is a weld defect that is the entrance or the entry of hydrogen molecules to the weld, producing that weld defect called porosity. Letter D, arc stripe, is also another weld defect or discontinuity that unintentional or intentional striking of the welding electrode to the other part of the base metal at or near the welded portion of the metal. So that leaves us to the answer, letter C, slag. Slag is the solidified layer formed during the SMAW process, enabling the molten weld pool of metal to be cooled and also to be shielded from the harmful effects of atmospheric gases. Next question. What are the specific functions of the electrode coating performed during welding? Letter A, provides a gas stream to shield the molten weld pool from atmospheric oxygen, hydrogen, and nitrogen contamination until it solidifies. Supplies the oxidizers and fluxing agents to clean the weld. Adds alloying materials to the weld pool, enhancing its properties. Letter D, all of the above. Basically, letter A refers to us as the shielding property of the electrode of stick welding. Letter B refers to us as the deoxidation process of the electrode. And letter C is basically the alloying characteristic of the electrode, basically adding the materials to the weld pool, enhancing its mechanical properties. All of these properties or these characteristics are a function of the electrode coating performed during welding, and thus the answer is letter D, all of the above. Next question. What type of electrode fits the following description? Tensile strength of 60,000 psi, suitable for all position, and has low hydrogen electrode. Letter A, 6010. Letter B, E7018. Letter C, E6013. Letter D, E6018. So letter A, E6010, is an electrode with 60,000 psi, so that might be the correct answer. Number 1 is suitable for all positions, so that might be a correct answer. But the last digit, so what does it refer to? So it's a chemical composition for that specific welding electrode. But is it a low hydrogen electrode? So for letter B, so you can automatically cancel that out because 70 pertains to as 70,000 psi strength for that welding electrode. E6013 might be the correct answer, but what does number 3 meant for that last digit? Letter D, E6018. So that is the correct answer because the last digit 8 refers to us as the low hydrogen electrode. Normally for low hydrogen electrodes, the last digit for SMAW ends with 5, 6, or 8. So that denotes a low hydrogen electrode. Next question. What problem does moisture entering the electrode coating cause in SMAU? Letter A, electrode temperature change. Letter B, short circuits the electrode. Letter C, introduce hydrogen to the weld causing brittleness. Letter D, none of the above. So when moisture enters the electrode coating, so what does it cause during the stick welding process? So does it change the electrode temperature? Does it short circuit the electrode? Short circuiting mainly focuses or mainly pertains to JMAW processes. So letter C is the correct answer, because when moisture enters the electrode, so basically it's H2O, when it breaks down, hydrogen can cause brittleness to that electrode coating or that molten weld pool in the welding process. So last question. What are the elements of the AWS identification system for SMAW? Letter A, the first 2 or 3 numbers refers to the minimum tensile strength. Letter B, the next number, second to the last number, refers to the position. Letter C, last number describes other characteristics by the coating present on the electrode. Letter D, all of the above. So if you can check the choices, the first 2 or 3 numbers indeed indicate the minimum tensile strength of the weld. The next number to that refers to the position, either 1 or 0. The last number is the chemical composition or any other characteristic that describes that electrode. So all of these 3 choices are accurate, so the answer here is letter D. This welding process is characterized by solid wire electrode which is fed continuously through a welding gun, commonly known as MIG welding. Letter A, FCAW. Letter B, SAW. Letter C, GMAW. Letter D, GTAW. So FCAW is characterized by a tubular electrode. So definitely that's not the answer. SAW is the submerged arc welding, which is an automatic welding process. GTAW is a welding process which consists of a filler metal or a filler rod with a tungsten electrode to heat and weld the metal. So that leaves us to the answer, letter C, GMAW. GMAW is a process wherein a continuously fed solid wire is produced or is continuously fed through the welding machine or the welding gun, thus affecting or reducing or improving the productivity of the welder and its process. Next question. This mode of GMAW metal transfer characterized by low average current and by pulsing of the welding current. So the GMAW process has 3 main mode of metal transfer. So what are those? So you need to also identify that because it's a common question in the CWI exam. Letter A, globular transfer. Letter B, short circuiting transfer. Letter C, pulse spray. Letter D, none of the above. So from these choices or from the question itself, so it indicates pulsing and low average current. So the answer here is fairly obvious, pulse spray. Letter C. Next question. This mode of GMAW transfer is utilized for small diameter electrodes and sheet metal welding due to its low amount of heat. This mode provides low penetration if used with argon and carbon dioxide mixtures. Letter A, pulse. Letter B, globular. Letter C, short circuiting. Letter D, none of the above. So when welding sheet metal using GMAW, you only need a low amount of heat and low amount of current to basically, because it's a sheet metal, so it's very thin. You don't need large amounts of heat to basically fuse them. So the answer here is letter C, short circuiting, because short circuiting has a low amount of heat and a low penetration, with its low current setting, and it's basically it's pulsing short circuit input to the weld. So globular is not the answer because it's a form of globules that is inputted to the molten weld pool. So when you use globular in sheet metal, so basically that will melt the sheet metal in itself because of the droplets. Next question. In this mode of GMAW transfer, the low arc voltage is used to minimize spatter and enable deeper penetration. Rate of transfer range from 20 to 70 droplets per second. Letter A, pulsed. Letter B, globular. Letter C, short circuiting. Letter D, none of the above. So the choices here, or the answer here, is fairly obvious as well because of the keyword here, droplets. So the rate of transfer range from 20 to 70 droplets per second, and it enables deeper penetration. So here, letter A, pulsed, and C, short circuiting, because it operates at a lower heat and current setting, it will not be able to provide deeper penetration of the weld. So the answer here is globular transfer because of the amount of globules that will be produced to the weld pool, so it will enable deeper penetration. Last question. What are the elements of a GMAW electrode? Letter A, ER denotes that the material can be used as electrode or welding rod. Letter B, the third to fourth or fifth digit indicates tensile strength. Letter C, final number is the chemical composition. Letter D, all of the above. So all of this characteristic of a GMAW electrode is accurate in terms of these choices. No? So the ER denotes that the material can be used as electrode or welding rod. So the next digits indicate tensile strength. So if it can be 70 or 100, so that indicates 70 KSI or 100 KSI respectively. And the final number, as similar to the SMAW electrode, is the chemical composition of that GMAW electrode. So the answer here is letter D. All of the choices are accurate in terms of the elements of a GMAW electrode. So normally the naming of electrodes, the electrode designations are common in the CWI exam. So you have to be familiar with those questions and in the naming of these electrodes. This process is similar to GMAW except that the electrode is tubular and contains a granular flux instead of a solid wire. So in this process, meaning similar to GMAW, is because that the wire is continuously fed as well to the welding gun. But except here, the electrode is tubular, not a solid wire, in the case of GMAW. Letter A, FCAW. Letter B, GMAW. Letter C, GTAW. Letter D, SMAW. So you can immediately cancel out GMAW here. So GTAW is gas tungsten arc welding. So it's not the correct answer because it consists of a tungsten electrode with a filler rod. SMAW is not a continuous welding process or a continuously feeding electrode process, so that's not the correct answer. So the answer here is FCAW. So FCAW is characterized with a tubular electrode that is continuously fed to a welding gun, similar to GMAW. Next question. FCAW electrode identification system is written as EXXT-X. What does T mean? Letter A, tensile strength. Letter B, tungsten. Letter C, transfer. Letter D, tubular. So when you're talking about FCAW, so it is a tubular electrode. So definitely, the letter T means tubular. So the answer here is letter D. So tensile strength, it refers to the first two digits or first 2 to 3 digits of this FCAW electrode identification system. So tungsten does not refer to FCAW, it refers to GTAW. So transfer, or the mode of transfer here, does not refer to FCAW but to JMAW. So you need to distinguish that. So for FCAW, when you see that T in that electrode identification system, that means tubular. Next, some electrodes are designed to provide all of the necessary shielding from the internal flux. What do you call this characteristic? Letter A, shielding gas. Letter B, gas shielded. Letter C, self-shielding. Letter D, both A and B. So for JMAW and FCAW, sometimes you need a separate shielding gas input to protect the weld from atmospheric gases. So for FCAW, one advantage of it is that it can be self-shielding. So meaning self-shielding is that the necessary shielding for the welding process comes from the internal flux. So in the tubular part of that electrode, it has that internal flux inside that tubular electrode, which produces that self-shielding characteristics. Basically, the shielding gas or smoke around the weld pool, similar to SMAW. So the answer here is letter C, self-shielding. For this question, an electrode is tagged as E70T-7. What does the second digit mean? Letter A, tensile strength of 7 KSI. Letter B, tensile strength of 70 KSI. Letter C, chemical composition. Letter D, all position. So here, that digit, the number 7 here denotes a tensile strength of 70 KSI, not 7 KSI. Because the number 0, that 0 here, refers to as the position for this electrode. So the answer here is letter B. So don't be confused with the tagging for FCAW, as it is slightly different for the naming of JMAW and SMAW electrodes. I have a video for the SMAW electrode naming that you can also see in this playlist or in this channel. An electrode is tagged as E70T-13. What does the last digit mean? Letter A, usability designator. Letter B, shielding gas designator. Letter C, position designator. Letter D, none of the above. So the usability designator is the second to the last digit here. So that's number 1. The position designator is the number 0 after the first digit, number 7. So the answer here will be shielding gas designator. So the last digit for a FCAW electrode designation is the shielding gas. So how can you know that is FCAW electrode? Is by looking for the letter T for the electrode classification system or electrode naming. So if you see here, that means tubular. So for tubular, that pertains to FCAW process.
This welding process makes use of pure or alloy tungsten with the ability to withstand very high temperatures. The electrode is not meant to be consumed. A. SMAW, B. FCAW, C. JMAW, D. GTAW. Now this welding process talks about making use of a pure alloy tungsten that is subjected to a very high temperature. So letter A, SMAW, is known as stick welding, so it uses a consumable electrode. So that does not match what is being asked in the question. FCAW is made up of a tubular electrode, so there's no tungsten in there. JMAW consists of a meters and meters of wire that is being fed to the gun, and it doesn't have tungsten in it. So GTAW, or gas tungsten arc welding, makes use of alloy tungsten that is subjected to a very high temperature, and it is fused with a filler metal or a filler rod that is being fused to the base metal as to weld it in place. So the answer here is GTAW, or gas tungsten arc welding, or commonly known as TIG welding. Next question. What will be the setting of the welding machine for GTAW if the welder intends to hit the base metal more? Letter A, AC. Letter B, DCEN, or DC electrode negative. Letter C, DCEP, or DC electrode positive. Or D, none of the above. So, welding machine commonly is, or commonly has the what we call as electronegative flow, right? So it flows to a circuit in an electric or an electrode negative flow manner. So for letter A, AC, so if it is AC, it will not heat the base metal more because of its sinusoidal kind of curve. If you plot it on a if you plot the current, so basically the electrode is not in contact, or it seems like it's not in contact with the metal for a very long period, or much more like SMAW. You can use AC because basically when you can run out of the electrode, you basically take out the contact of that filler metal to the base metal. So it is okay to use AC for that. Letter C, DCEP, heats the base metal more for SMAW because of the electronegative flow. Basically, the base metal will be heated up more because of that kind of circuitry or circuit flow. So the answer here is letter B, DCEN. So for GTAW, one thing you can remember in the CWI exam is it is some sort of opposite the electronegative flow or the flow of the current from SMAW, which is DCEP, if you want to heat the base metal more. So basically, if you want to heat the electrode more, you need to have DCEP for GTAW. So it's kind of opposite or opposite philosophies for GTAW and SMAW in terms of the electrical characteristics of the two process. So something to remember. Next question. What is the color designation of pure tungsten electrode classification for GTAW? Letter A, yellow. Letter B, orange. Letter C, green. Letter D, red. So there's no way around this question but to memorize the different electrode classification for GTAW or the designation for the electrode classification for gas tungsten arc welding. So for pure tungsten, the color designation of it is letter C, green. So something to remember is, as this is a common question in the CWI exam. Next question. What will be the setting of the welding machine for GTAW if the welder intends to heat the electrode more? So this question was kind of preempted when I asked the previous question. So letter A, AC. Letter B, DCEN. Letter C, DCEP. And letter D, none of the above. So here, as I've said earlier, if you want to heat the electrode more for GTAW, you will have to use DCEP. So it's kind of opposite with SMAW. When you want to heat the electrode more, you will use DCEN. And if you want to heat the base metal more for SMAW, you need to have DCEP. So reverse for you will also need to remember that the DCEN is known as straight polarity, while DCEP is known as reverse polarity. So kind of have you might want to know those nomenclatures for the electrode characteristic or the electrical polarity of the welding processes, because it might not the questions might not ask or might not have the choices as DCN or DCEP. They might say it as straight polarity or reverse polarity. I might have mix it up, but you can basically search it up if you want to confirm the equivalency of DCAN if it is straight polarity or reverse polarity, something like that. So you can do your due diligence as well. So next question. What is the most inherent welding discontinuity in GTAW that is totally confined within this welding process? So letter A, tungsten inclusion. Letter B, arc strike. Letter C, porosity. Letter D, none of the above. So the question that is being asked here is, what is a welding discontinuity that is totally confined or totally exclusive with GTAW? So if you are familiar with the process, even if you're not that familiar with the discontinuities or the defects that comes around typically with this process, you will know from the name itself, GTAW or gas tungsten arc welding, because of the electrode consisting of tungsten, you would know that it is exclusive with GTAW, that tungsten inclusion is exclusive to that process, because no other processes or welding processes have tungsten in it. So as you can see here, the welding gun for the GTAW, you can see here the non-consumable tungsten electrode. So GTAW has that in its process. That's why tungsten inclusion has, or it is exclusively a discontinuity within this process. So that's one of the reasons I think AWSD 1.1 does not automatically pre-qualify GTAW because of this discontinuity. No. So basically there are processes that can be automatically pre-qualified without qualifying in a PQR. So GTAW is one of those processes that cannot be automatically pre-qualified. You need to abide by the qualification process of clause 4 of AWSD 1.1. This welding process is characterized by a continuously fed solid wire electrode which provides an arc totally covered by a layer of granular flux. So the question basically is asking what is a welding process that involves a continuously fed solid wire electrode, and as soon as the this solid wire is in contact with the base metal, an arc is formed together with a layer of a granular flux. So letter A, SMAW. B, GMAW. C, GTAW. D, SAW. So letter A, SMAW or SMAW does not involve a layer of granular flux. So basically the flux is being processed through that smoke coming out of the electrode coating of the electrode, from the coating of that electrode, from that stick electrode of SMAW. So that flux is being so to speak burned and protects the weld pool from the atmospheric gases. So that's not the answer here. So we have basically a flux here, or a layer of a granular flux. It's like a sand basically. So GMAW, while it has a continuously fed solid wire, does not have a granular flux. Letter C, GTAW does not have a continuously fed solid wire. It has a tungsten electrode with filler metals that you have to basically fuse to the base metal. So letter D, SAW or submerged arc welding, that's why it's the term is submerged, because the arc is submerged in a layer of granular flux, and it is a continuously fed solid wire electrode through that machine. Basically it can be considered as an automatic or a semi-automatic process because of its continuous wire feeding and a controlled travel speed. Basically the machine you can control the machine's travel speed automatically, unlike for SMAW, GMAW, and other process where the travel speed is being controlled by the welder itself. So a welder here is not needed, but an operator, basically to set up the machine
to basically set the speed of the wire feeding and the travel speed of the solid wire. The flux here is automatically being consumed by forming a layer into the weld. So the answer here is letter D, SAW, or submerged arc welding. Next question, which of the following is the limitation of SAW? Letter A, can only be done in vertical position. Letter B, a manual welding process. Letter C, weld deposition in small amounts. Letter D, can only be done in position where flux can be supported in the weld joint, normally in flat or horizontal positions. So here in SAW, the one thing that its limitation is it cannot, I repeat it cannot be done in vertical position. So letter A, it's automatically eliminated. So letter B, a manual welding process. So as I've alluded earlier, it can be considered as a semi-automatic or an automatic process because you can control the wire feeding and the travel speed. So letter B is not correct. It's not a limitation because it's an automatic process. So letter C, weld deposition in small amounts. Because submerged arc welding can be an automatic process, and because of its continuous wire feeding and basically have a big machine there, it is known for depositing large amounts of weld pool or weld metal in the base metal. So that's not a limitation of SAW. So as you can basically understand from now is letter D is the answer because it can only be done in position where flux can be supported in the weld joint, normally in flat or in horizontal position. So you can just imagine, so the answer here is letter D. So you can just imagine if the welding machine is put in a vertical position, so the flux will fall because it cannot be supported in the weld joint. Because of gravity, it will just keep falling down. So if you can imagine, a flux is like a sand covering the weld. So its primary purpose is to prevent moisture from creeping into the weld, much like the electrodes needed to be stored in the oven. So basically, this flux also has a proper storage procedure to be followed as well. So basically here, the limitation basically of SAW or SAW is that the machine must be configured or must be configured in such a way that the flux will not fall to the ground, because if it is contaminated, you cannot use it. So it will just be wasted. Which of the following is false regarding granular flux for submerged arc welding? Letter A, flux is placed into a hopper above the welding torch and fed by gravity. Letter B, flux is forced to the gun using compressed air. C, flux when properly stored can cause moisture from creeping into the weld. Letter D, flux may prevent the welder from seeing the arc with respect to the joint. So let's run through the choices here. So flux is placed into a hopper above the welding torch and fed by gravity. So this is correct. This is true because the flux is basically fed into the hopper above the welding gun, and as it falls through the hopper, it falls down to the weld arc itself or the base metal to be joined. So it just falls through gravity by the hopper. So the flux is forced to the gun using compressed air, so that is true as well. So it is for it to be loaded into the welding gun, the machine uses compressed air. So since the flux is a granular or is a solid, it is made up of solid sand, or it is made up of basically like sand, it may prevent the welder from seeing the arc because from the term itself, submerged arc, the arc is submerged through this granular flux. So letter D is also true. That might be an issue with the welding operator. He might not see the arc. One thing that you can remember, or one safety precaution that you may bypass in SAW, is that
you may not use welding helmet or goggles, because, or you can just use goggles because the granular flux might go through your eyes. But the normal welding helmet, to prevent you from seeing the flash, because basically flash in SAW is non-existent, because yeah, the flux is covering the arc. So that's something to remember as well. So the answer here is letter C. Or I'm sorry, the answer here is letter C, not D. So that's a typo. So flux for SAW is like a sand covering the weld. So its primary purpose here is to prevent moisture from creeping into the weld. So the, as I've alluded to in the previous question, so the flux needed a proper storage procedure, much like the electrodes needing to be stored in an oven. So not to contaminate the flux. So if it is properly stored, it can function properly, as to not let moisture creep into the weld. So it must be stored properly to preserve its function. So to prevent the weld from atmospheric attacks, basically from hydrogen, oxygen, and all those kind of stuff. So the answer here is letter C, not D. Which of the following is the advantage of submerged arc welding? Letter A, high deposition rates. Letter B, non-existence of slag. Letter C, flux promotes accumulation of moisture in the weld. Letter D, none of the above. So basically, flux is a sand. It's basically slag itself. No? So letter B is not the answer. So basically, you have slag in it. But you can just remove it easily because it just covers the weld arc. It doesn't stick basically on the weld, unlike unlike stick welding. So flux promotes accumulation of moisture, so that cannot be further from the truth. Flux basically prevents moisture into the weld, so that's why it's covering it. But the one advantage of submerged arc welding is high deposition rates. If you want high deposition, you want to fill that metal in with, if it's very thick, like a 20-inch or even 60-inch metals. I've seen some factories that weld steel plates almost, I think 1.5 to 2.5 inch thick. Basically it is a submerged arc welding. So basically it can produce high deposition rates of weld. So the answer here is letter A, high deposition rates. Remember that if you want to deposit or if you want high deposition rates, use SAW any day of the week. It will produce your desired weldment into a thicker metal. So next question here, F7A6-EM12K is a SAW electrode or a SAW electrode. What does F and the digit 7 mean? So letter A, iron, 70,000 psi strength. B, flux, 7,000 psi strength. C, flux, 70,000 psi strength. D, iron, 70,000 psi strength. So for the nomenclature of the SAW electrode, so F means flux. So for SAW, flux is included in the designation. The digit 7 here is 70,000 psi strength or 70 ksi. So I might do a video regarding this, discussing the SAW electrodes and its nomenclature. So the answer here is, of course, letter C, flux, with 70,000 psi strength. Who does a welding inspector talk to primarily if there is a case of multiple rejects in a weld by a welder? This personnel is present especially for big construction projects. So I basically have this experience wherein there is a multiple rejects produced by a welder, and as an inspector, as an engineer, who did I talk to address those issues? So A, welder. B, the welding engineer. C, welding foreman. D, the design engineer. So basically, if you direct your communication, or you confront the welder, so maybe it may ensue a confrontation between you and the welder, because for typically for big construction projects, it has a tight schedule. So the pressure might be on the welder to produce multiple welds at that tight deadline or tight schedule. So it might not be a good idea to confront him directly if it has multiple rejects, or he produced a multiple rejected welds. So letter B, welding engineer, basically is not responsible for this because he created the welding specification. So he will not be the one the welding inspector needed to talk to in this situation. Letter C, the welding foreman, is a good answer because the welding foreman basically he's the reporting supervisor for the welder. Basically, he has the rapport and the empathy to talk to the welder in case of multiple rejects and explain to him how he can rectify those defects. So letter D, the design engineer. The design engineer, he's responsible for creating the specification or the drawing that is needed to be implemented during construction, or the one that is referenced by the welder in terms of welding the structures or the components, basically to build it. So the answer here is the welding foreman. The foreman can communicate directly with the welder for the defects without a confrontation. So next question is, this is known to be the best quality for a welding inspector. A, maintenance of inspection records. B, good physical condition. C, professional attitude. D, experience. So basically, all of these qualities of a welding inspector is good. So what is the best amongst all of them? So letter A, maintenance of inspection records. Basically, some proponents or some owners of the plant, for example, needed the inspection records for reference in the future. So if there is a similar defect that occur in the plant, they may refer to that inspection record. So it is important for the welding inspector to maintain those inspection records in good condition, so it can be referenced in the future, and it can be a good reference for those similar conditions that will happen. Good physical condition. Basically, the welding inspector needs to be in good physical condition for him to go to tight areas, confined spaces, hard to reach areas, or areas with at high elevation, basically. So he needs to be in good condition for that. See, professional attitude. So this just the quality of a welding inspector to provide unbiased opinions based on facts, make his decisions based on facts, and to continuously learn throughout his tenure as a welding inspector. The experience, experience basically enables the welding inspector to become more efficient in his work activities. Basically, he can streamline those activities and become more efficient of providing judgment in terms of whether to pass the weld or not. And basically, because of his experience, he has a knowledge of good reference knowledge of what or how he can pass those or reject those weld that he inspected. The answer here is letter C. So this enables professional attitude. This enables the welding inspector to conduct himself properly in the workplace and to continuously learn. By the way, so you can pause the question or pause the video at any time if you need to think of the answers prior to me explaining the rationale of each of the choices. So you can do that. So what do you call a body of law which, if used in a job specification or contract, can be exerted with the full legal authority of the law? A, code. B, standard. C, specification. D, all of the above. So basically, a standard is a reference document in which the
specification of an equipment, or in this case a weld, is basically compared to if it complies with the acceptance criteria. The specification is just a list of parameters, on it, not to go on a tangent, but the welding procedure specification is the best example for a specification because it lists the needed specs for the weld. For example, the electrical current, the base metal, the filler metal, and the technique for the welding as well. So the answer here is A, code. So for example, if AWSD 1.1, which is a code for structural welding of structural steel, is used and is called upon in the contract or job specification, if accidents happen or lapses are made during construction of that project or that maintenance activity, and is found that there are non-compliance with the code, the engineer on record or the ones responsible for it may be called upon or subpoenaed in a court of law to basically be questioned regarding his compliance or lack thereof of compliance with regards to the code that's supposed to be used in that contract. Next question. Which of the following is not a standard used in the CWI examination Part C? So the Part C of the CWI exam is basically an open book where the examiner must choose in the following standards or in a set of standards. So basically, he doesn't need to be just inspecting that code or standard when he passed the exam. He basically can do it, but in the CWI exam, you need to choose just one. So which of the following in this question is basically what you can choose? So A, AWSD 1.1, B, API 1104, C, ASME 9, D, API 610. So AWSD 1.1, as I've talked about earlier, is the structural code for steel. API 1104 is the welding of pipeline and related facilities. ASME 9 is welding and brazing procedure qualifications. But basically, AWSD 1.1 also has a pre-qualification of welding procedure specification. And letter D, API 610, is for centrifugal pumps for petroleum and petrochemical industries. So the answer here is letter D, API 610. This for centrifugal pumps used in petroleum and petrochemical industries. This is not used as a standard in the open book part of the CWI exam. Okay, so last question for the day. So the welding inspector is considered to be blank of the welding engineer in the field. So letter A, right hand, B, assistant, C, lead, D, eyes. So basically, this what happens between how you can inspect the quality of the weld. So there's what you call a quality assurance and the quality control. Basically, the one responsible for the quality assurance, meaning the creation of specifications, the quality standards, is the welding engineer. So basically does that and implements that in a construction project or in a maintenance activity in the plant, for example. So the welding inspector is in charge of the quality control, meaning he validates if those weld is complying to the welding or quality standards that the welding engineer produces or implemented. So from that idea, you can basically have a deduction of what is the right answer here. So letter D, eyes. So the welding inspector is in charge of the quality control of the specifications created by the welding engineer, hence the eyes. Which of the following is not a function of a welding inspector? A, prepares inspection procedure. B, qualify or certify welders. C, auditing of vendor providing services but not the materials. D, ensures conformance with the codes, standards, and specifications. So basically, these are the functions of a welding inspector. So A, the welding inspector prepares inspection procedure. So
he documents how he will go about inspecting the weld during the activity, so during the welding activity. So he can impose an inspection points, where he can witness the welding activity and provide what tests will be done for the welds, so to ensure the quality, and for him to make a decision whether to pass or fail the welds. Qualify or certify welders. So there's a document called the welder's qualification test. So the welding inspector also provides qualification and certification for the welders for a specific type of welding activity, or for a certain position and for a certain material. Basically, that document outlines that. Letter C, auditing of vendor providing services but not the materials. So for example, when a refinery is in a shutdown or a plant is in shutdown, so the welding inspector may be instructed to audit the vendor providing the services, but the last phrase is not good, because he's also in charge of providing audit or inputs to the base metal or the materials that will be used in welding. The documents like MTRs, mill certificates, the factory standards that is used for the base metal, the production of the base metal, the testing or the destructive testing used prior shipment is also should be analyzed and scrutinized by the welding inspector. So letter D, ensures conformance with the codes and standards and specifications. So this is part of the basic function of a welding inspector. He needs to ensure that the weld quality, the base metals, and other aspects of the welding activity is in conformance with the codes, standards, and applicable specifications. So the answer here is letter C. So the welding inspector needs to also check the material specification that will be used in welding. Basically the base metal, not just the filler metals and the weld quality itself. It needs to be a holistic approach. Yeah, the inspector is also responsible for the quality of the base metal, as this can lead to failure if not checked. So basically, if you check the weld but you didn't check the base metal, so it will result to a failure eventually. Next question. If the inspected weld is found to be an IJP or incomplete joint penetration, what should the welding inspector do first? So this is basically a situational question. Reject the weld as it has incomplete penetration. B, pass the decision to the NDT specialist. C, clarify the drawing and consult with the design engineer. D, ask the welder to completely fill the weld joint. So basically, this is part of the communication that the welding inspector needs to conduct during his day-to-day activity. Basically, here is letter A. It states that you need to reject the weld as it has incomplete penetration. So basically, if some welding procedure or some specification or drawings may not accept incomplete penetration, so that can be an answer. Letter B, pass the decision to the NDT specialist. So not quite. So basically the choice here is vague. So you may not need to pass the decision to an NDT specialist here. So it needs not to be specific to a non-destructive testing specialist. So it's just incomplete joint penetration. Basically, you can see the discontinuity or the defect just by looking at it. So the NDT specialist might not be the one, or he may not be the the one that needs to be consulted immediately. So letter C, clarify the drawing and consult with the design engineer. So basically, some specification or drawing specifies if the structure or the components to be welded are just incomplete joint penetration. So it may be acceptable for some drawing or design documents. So you may need to consult your design engineer for this one. Ask the welder to completely fill the joint. So from my point earlier, so you need to consult the designer of the structure or the components if it is indeed an incomplete joint penetration. So the answer here is clarify first the drawing and consult with the design engineer. So you need to be in consultation first with the appropriate personnel that design the joints or structures. Next question. The term used to delay a production or construction schedule to allow inspection of a component or components of the work. So basically, this term is indicated in the inspection test plan. So letter A, pre-construction, B, inspection point, C, witness, D, hold point. So letter A doesn't make any sense. Basically, pre-construction doesn't align with what the question is asking for. Inspection point is a more general term for this one. Witness is one of the points that is indicated in the inspection test plan. D, hold point. Basically, this is the answer. It delays the production or construction schedule to allow inspection of a component. So what's the impact of a hold point? No? The hold point is if the inspection did not yield a positive outcome, the succeeding work activities related to that activity will not be able to start unless the test yielded a positive result. For example, the welding inspector may need to inspect first the weld joint preparation done by the fitters or the welder itself before proceeding with the root pass, the hot pass, etc. So he may ask or indicate in the inspection procedure or the test plan that the inspection for the joint preparation is a hold point. Thus, if he finds it unsatisfactory, the welder needs to rectify the joint preparation to the acceptance criteria so as to proceed with the succeeding activity, basically to weld the joint. Next question. Which of the following is not a good practice for maintaining an inspection record? Signing the inspection record, indicate the job name, location, and specific test information, ink or typewritten. Basically, the inspection record needs to be in ink or it is typewritten by a computer. The errors are single lined out. So letter A, so the welding inspector or the one that created the inspection record needs to sign the inspection record. So he needs to be accountable for it, basically, by signing his name. Indicates the job name, location, and specific test information. So it is essential that the inspection record has a corresponding job activity where the location may be. For example, if it is a plant where the specific location, the activity is conducted in that plant, in the production area, for example, and the specifics of the testing that is done. So what is the acceptance criteria, what tests, procedures are done, etc. And it needs to be in ink or typewritten. For errors must be single lined out, and what is missing in this choice, it needs to be initialed. So if errors are made during the remarks or indication of remarks in the inspection records, it must be single lined out and initialed by the one who did it. Basically, it is the welding inspector that made those remarks. So if he has errors on it, he needs to be initialed as well. Last question. So NDT personnel other than CWIs are typically certified to what document? Letter A, AWS QC1, B, AWS D1.1, C, API 1104, D, ASNT SNT TC1A. So the answer here is letter D, ASNT, which stands for American Society for Non-Destructive Testing. Basically, these certifying body provides certification for NDT professional. The most important part of an effective safety program is compliance of personnel, B, protective equipment, C, management support, D, safety rules. So in order for a safety program to be effective, what do we need basically? So what is the most important aspect of it? So letter A, compliance of personnel. So compliance of personnel is needed basically for an effective safety program to be conducted, but it's just one piece of the puzzle basically, but it's not the most important part. Protective equipment is also important, but in terms of, if you remember the hierarchy of a safety program, so basically the first one is elimination of hazards, substitution, engineering and administrative controls, and the last one is PPE, right? Because it is the last line of protection for the personnel against any hazards. So basically it is important, but basically it is in the last part of that hierarchy. Letter C, management support. So like any other programs, maybe it's safety, quality, etc. So the management support is important for everyone's buy-in and compliance for an effective safety program. Safety rules is basically what entails that safety program. So the rules and regulations and the program itself, or what consists of the program itself for that safety program. So the answer here is letter C. So management support. So unlike any organizational program, management support is needed to have for everyone's buy-in and compliance with the safety program. It needs to start from the top basically. Next question. This is a type of permit used for welding, cutting, or similar activity is done to areas not normally assigned for such operations for the purpose of alerting the area supervisors. So letter A, cold work permit, B, hot work permit, C, vessel entry permit, D, no permit is needed. So for the first choice, so cold work permit, it is just for a work activity that doesn't produce sparks or doesn't generate any heat. So that's cold work. Hot work is for welding, cutting, that use oxyacetylene for that example. Basically the one that generates fumes or generates heat for that activity. For refineries, for plants that is normally not designed for any welding activity or any hot work activity, hot work permit is needed to alert the area supervisor of any activities that will generate heat, that will be a hazard to the plant because it might ignite the fumes. For example, in an oil and gas refinery or a petrochemical refinery, petrochemical plant that normally generates a fumes. So these hot spatter or generated heat might ignite those, basically creating fire. So vessel entry permit, this is used for confined spaces that needs to be validated first of its oxygen level before any activity is conducted or commenced. No permit is needed. So basically it is dangerous if we do not have any oversight for what mitigations or precautions the welders or the supervising personnel is doing for that hot work activity or for that welding or cutting activity as stated in this question. So the answer here is letter B. So it alerts the area supervisors of the areas in which hot work activities are going on, enabling him to prioritize the firefighting resources if needed be. So for example, mitigations are in place, everything is fire extinguishers, but basically it was not enough. The fire generated just spread throughout the area. So if you have a hot work permit, basically it alerts the supervisors to prioritize those firefighting resources, the hydrants, the hoses, the fire trucks to that area. Which of the following is not considered a shielding gas? So shielding gas basically protects the weld from atmospheric gases, basically from embrittlement and contamination of hydrogen. Basically a shielding gas enables the quality of the weld from being contaminated by those gases. So in this question, what is not considered a shielding gas? Argon, helium, carbon dioxide, carbon monoxide. So one of the basic traits of a shielding gas, it needs to be inert. So argon, helium, carbon dioxide are normally used as shielding gas for a lot of processes, basically for GMAW, GTAW. For SMAW, it also has a shielding gas, which is generated from its flux or coating, electrode coating. So the answer here is carbon monoxide. So it is emitted as one of the harmful fumes or gases during welding, but it is not considered as a shielding gas. Next question. What is the reason why compressed gas cylinders are returned when there is still 25 psi of contents remaining? So basically, this is a practice of handling compressed gas cylinders. So why is there a need to return it when there's still 25 psi? Is it not a basically is it not wasteful to just return it when you know it has contents? So what is the reason behind this one? A, because the trained personnel is used to filling contents without remaining pressure inside the cylinder. B, to prevent atmospheric contamination of the cylinder. C, to avoid explosion or combustion of the cylinder. D, none of the above. So letter A, basically, the trained personnel is true. It is true that it's used to filling contents without remaining pressure. But the question here is, what is the reason behind it? Letter B, to prevent atmospheric contamination of the cylinder. This is a good answer because basically, if you have a pressure contained in that cylinder, the atmospheric gases will not be able to enter it because the pressure of the atmosphere is what? 14.7 psi. So basically, it will not be able to contaminate the contents of the cylinder. So letter C, to avoid explosion or combustion of the cylinder. This might be problematic, but in order for the cylinder to explode, it needs to have a source of heat. So basically, in this example, there is none. Letter D, none of the above. So the answer here is letter B. To prevent atmospheric contamination of the cylinder, the remaining pressure will serve as a seal, preventing the atmospheric gases from entering the cylinder. So the last question for this set is, to prevent fumes during welding, the most important factor is the type of base metal, the type of welding process, C, the type of filler metal, D, the position of the welder's head. So to prevent fumes during welding, so what will be the most important factor? Meaning the most important factor is the one that you can control, basically. So letter A, the type of base metal. Basically, different base metals have different production of fumes. So as letter B, the type of welding process. So different because of different filler metals that is used, different base metals, and the flux that is used for that specific filler metal, and the duty cycle used in the welding machine. So it differs depending upon the welding process. So letter C, the type of filler metal. So as I've mentioned, depending on the composition of that filler metal. Letter D, the position of the welder's head. Now this is the most important factor during to prevent fumes, as for example, during the design of the welder's helmet, the ANSI standard for safety of welding, basically it has a clause wherein you need to conduct samples of the design for the design of the welding helmet near the breathing zone of the welder's head. So that's how important it is, the position of the welder's head. You need to sample that breathing zone to have a baseline in terms of designing the welder's helmet. Yeah, so the answer is letter D. It is the most important factor as this has the most exposure to the fumes, and not only the welder's helmet but also the ventilation, the type of ventilation used for that activity must also be designed to accommodate the position of the welder's head. This element or elements, when present in metal, can produce or cause what they call metal fume fever. A, zinc or copper. B. Asbestos, C. Fluorine, D. None of the above. So letter B, asbestos, it is now known to be a cancerous substance or a very harmful substance. Basically, before you use it or use it in any type of project or maintenance activity or repair, rehab, basically you need to consult with the local authority for the use of asbestos. Letter C, fluorine, it is one of the elements or compounds used in the coating of the electrode. So the answer here is letter A. So letter A is zinc or copper normally produces fumes that can cause nausea or what they call a metal fume fever. Next question. Which of the following statements regarding oxygen is true? Letter A. Oxygen less than 23.5% creates a fuel-rich environment. Letter B. Oxygen is non-flammable but supports combustion. Letter C. Oxygen below 19.5% can still support life. Letter D. Both A and C. So basically, the CWI exam has this types of questions. The last choice is basically it will opt you to choose between both or two answers. So let's explain each. So letter A, oxygen less than 23.5% creates a fuel-rich environment. Actually, if it is above 23.5%, it will create a fuel-rich environment. So this is especially important for confined spaces, wherein before you start welding or before the welding activity commences, the safety or the safety personnel needs to check via a gas detector or whatever instrument if the confined space has enough or will not exceed 23.5% threshold for creating a fuel-rich environment. So letter A is not correct. Letter B, oxygen is non-flammable but supports combustion. Yeah, this is a good answer. Basically, oxygen is not flammable by itself, but if you will remember the fire triangle, so basically oxygen is one of the components need to support combustion. So letter C, oxygen below 19.5% can still support life. Actually, the 19.5% is the threshold. If you reach below that, the oxygen level for that confined space or any area will not be able to support life. So the answer here is letter B. Oxygen is non-flammable but supports combustion. Next question. Which of the following statement is false? So letter A, primary shocks cause physiological harm. Basically, this question is regarding electric shock. Letter B, primary shocks are currents greater than 6 milliampere. C, secondary shocks are currents from 0.5 to 6 milliampere. Letter D, secondary shocks can cause death. So which of the following statement is false? So by the way, you can pause at any time if you want to think of the correct answer. So the answer here is letter D. So why are the others incorrect? So primary shocks can indeed cause physiological harm. So these shocks are greater than 6 milliampere. So letter B is also correct. Letter C, secondary shocks are indeed classified from 0.5 to 6 milliamperes. They don't cause physiological harm. They might cause minor tingling of the senses or the muscles, involuntary movements of the muscles, but they will not cause physiological harm or irreversible harm to the organs of the person if exposed to that kind of current. Next question. Acetylene should never be operated above blank PSI. So what PSI is that? A15, B20, C25, D30. The answer here is letter A. So above 15 PSI, the acetylene can become highly unstable and can explode. So acetylene is a highly volatile gas So if it is operated or pressurized above 15 psi, it can explode the cylinder, so it can cause accidents. So it should never be operated above 15 psi. So you need to also check the manual of the acetylene cylinder before operating it, just to be sure. The last question for this set is, hot spotter can travel up to blank feet. So letter A, 15, B, 20, C, 35, D, 30. So the answer here is, so this is a basic question regarding welding safety. The answer here is 35 feet. So this is the reason why workplace must be free of combustible materials, as this hot spotter is still very flammable and combustible, and it can kickstart a fire if it is in contact with the combustible materials like wood, paper, etc. So if this is not possible, so you have to provide fire blankets, fire coverings, fireproof coverings for the possible combustible materials that can be ignited by hot spotter. A fire watch can also be assigned at site to have a continuous stream of water and basically be on a watch for those hot spotter being spread throughout the workplace.
For the first question, this welding process operates by heating the metal with an electric arc between a covered metal electrode and the metals to be joined, more commonly referred to as stick welding. Letter A, SMAW. Letter B, GTAW. Letter C, GMAW. Letter D, SAW. So for the choices, GTAW is gas tungsten arc welding or TIG welding, so that's not the correct answer. Letter C, GMAW or MIG welding is also not the correct answer because it refers to as the gas metal arc welding or MIG welding. Letter D is SAW or submerged arc welding. It is a fully automatic process. So the answer here is stick welding is known as SMAW. So as you can see here, the flux coating or the electrode produces a shielding gas that protects the weld pool from harmful atmospheric gases that will embrittle the weld. So that's the basic principle of SMAW. Next question. This is one of the characteristics of the electrode coating in SMAW, where it decomposes to form a gaseous shield for the molten metal. Letter A, shielding. Letter B, deoxidation. Letter C, alloying. Letter D, insulating. So for the choices, deoxidation is the process or the characteristics of the electrode that removes the impurities from the molten metal. Alloying refers to as the addition of elements that will improve the mechanical properties of the weld. Insulating is the property of the electrode that produces a solidified slag that will prevent the sudden drop of temperature for the weld, thus preventing embrittlement. So the answer here is letter A, shielding. It is the characteristic of the electrode coating where it decomposes to form a gaseous shield for the molten metal for the purposes of protecting it from harmful gases that will embrittle the weld or cause unattended weld defects. Flux coating improves the electrical characteristics to increase arc stability. What do you call this characteristic of the flux coating of SMAW? Letter A, shielding. Letter B, deoxidation. Letter C, alloying. Letter D, ionizing. So the answer here is letter D. So as I've mentioned in the previous question, shielding is the property or the characteristic of SMAW wherein it prevents harmful gases from entering the molten pool of metal, from contaminating the weld, and causing embrittlement. Deoxidation produces chemicals into the weld that will oxidize the molten pool of metal. Alloying, as I've mentioned earlier, also produces the elements that will improve the characteristics of the molten pool of metal and thus improving its mechanical properties. So that leaves to us the letter D as ionizing, which is the correct answer, which is the improvement of the electrical characteristics to increase arc stability. So arc stability is very important during stick welding because it's a manual welding process, because you need to ensure that the creation of arc during the welding process is stable so as not to produce a defect. Next question about welding electrodes. What does the first two digit of this SMAW electrode mean? E7018. A weld diameter of 0.7 mm, tensile strength of 70 MPa, tensile strength of 70 KSI, letter D, low hydrogen electrode. The answer here is letter C. So the first two digits of this SMAW electrode is the number 70 or 70. So the first two digits, or the first two to three digits of GMAW or FCAW because it has a continuously feeding electrode with them. So that's it. If you want to kickstart your
I hope that this video helped you go through the topics of welding processes and welding safety that will surely appear during the CWI exam. If you already passed the CWI exam or are curious about the WPS and PQR, or want to know about writing and reviewing those documents, click those videos right here.